Hi, my name is Nathan McKinley, and I'm a software engineer on Google Cloud. Today, some systems administrators and DevOps folks find themselves facing a problem. They're currently supporting successful businesses, running, deploying, and managing large applications with Puppet. They have tens, hundreds, maybe thousands of servers in co location facilities or even in data centers. It's a good situation to be in, for sure. However, the technology world changes fast, and many of you are migrating or thinking about migrating to the cloud. There are dozens of places where you've already heard about the cost savings, the simplicity, the ease of scaling your application, the reduced overhead of management. There are many reasons that a team might consider moving their application into the cloud. But these benefits come with their own set of challenges, because there are many differences between managing your own servers in a colo and running instances using cloud best practices. You'll find very quickly that the cost savings and scaling advantages depend on running and managing your infrastructure very differently than you do when you've got dedicated machines. For example, dynamic scaling is not very important if you own the servers that your application is running on. You've already paid for them up front, and the cost to keep them running, even under extremely light load, is pretty low relative to your fixed costs. By contrast, in Google Cloud, you pay nothing up front, but you're billed by the minute for instances that you've created and have running, which means that to take full advantage of the cost savings that Google Cloud has to offer, you'll be constantly changing the number of instances that you have running, which would present a challenge for a traditional infrastructure setup. In today's talk, I'll be showing you how to overcome those challenges and perform what's called a lift and shift migration from an on-premises Puppet master agent configuration to a GCP project. A lift and shift is a type of migration where you transition from an on-premises application, where the code is running on servers that you own and administer, to the cloud, without doing a substantial re-architecting of your application. In your existing Puppet master agent configuration, you have a box on your network which contains all the manifests and modules that you've worked hard on and painstakingly assembled over the lifetime of your application and infrastructure. They define everything about your application, and they're the result of days, months, or maybe years of effort. The other boxes on the network talk to this machine, the Puppet master, to understand how they should be configured, and then automatically configure themselves based on those manifests. I'm going to change topics here for a second and say something that I think we mostly already know, and that's that software is weird. We spend so much time immersed in it that it's not always something that we notice, but it's true. Software just isn't like other stuff. We try to explain software with metaphors to the physical world, but because of its uniqueness, those metaphors always end up breaking down. Take, for example, a house. You can spend years working on a new house, designing, building, tweaking. But once that house is done, if you want another house just like it, well, it's still going to take at least a couple of months, maybe another year. You've learned a lot from your first construction project, but the physical world is involved. Someone has to buy the wood, hold the hammer, climb the ladders. But with software, say you built some complex backend, it also took you years to design, build, and tweak. But if you want another copy of your software, you can just push a button or type a few commands, and bam! You put in years of work to build the thing, and now you can have as many copies as you want. And there's more. If you want to change your software, you can, more or less, change it everywhere at once. But let's say you did build 50 houses over the course of probably decades. If you ever want to change the color of the window shutters, you're going to need 50 folks on ladders. And the reason I mention this is that on premises, servers are a lot more like houses than they are like software. If you want another one, you have to find somebody to sell it to you, somebody to install it, and you got to get it hooked up to the rest of your boxes. Puppet solves the last step, the configuration, changing the color of the window shades, but the physical world is still involved in building a new one. Someone has to move things around and plug stuff in. But the cloud just is not like that. In the cloud, servers are software, they're not houses. You can spin them up, spin them down, copy them as many times as you want. In the cloud, it's just not necessary to configure your machines the way that you used to. Since servers are software, you can configure a machine once and clone it as many times as you need. This is exactly what you'll want to exploit in Google Cloud to support dynamic scaling. So, if in the cloud you don't need to configure machines after they come up, because of course they can start as a clone of a machine that you've already configured just the way you want it, you might ask, what will we use Puppet for in the new cloud first world? Plenty. Puppet is much more than just a tool for distributing configuration, of course. It's a tool for defining and applying that configuration as well. In today's demo, we're going to talk about moving an application from Puppet on premises to GCP, but the only tool that we're going to use to do this is Puppet. Let's talk about how we're going to do that. First, I'll show you the app that I've set up to emulate the on-premises app that we're trying to lift and shift to the cloud. Over here, I've got two servers that I have sitting around, one that I've configured to be the Puppet Master, and another that I've configured to be a node, which is speaking to the Puppet Master via the Puppet agent. We can take a look at the very simple PHP app that I am deploying to the Puppet agent. First, we create a directory, install Apache, set up a vhost, and serve a very simple PHP app. Of course, the apps that you'll be working with are much more complicated than this simple thing that I've put together, but most of the same principles apply, and you can see the README in the associated GitHub repo for this talk to understand a couple of ways that you can apply these principles to more complicated setups. So let's go ahead and apply this simple manifest to our Puppet node using the Puppet agent. Down here, you'll see that we have a watch on curl on the local machine, which is trying to connect to the Puppet node, just so that we can see when the app has been successfully deployed. We see that something's happening. There we go. Hello from Puppet agent, and you've got the date time right down there. A naive migration of this application to the cloud might end up looking something like this, where we'd create a GCP instance for the Puppet master, as well as a GCP instance for the Puppet node, which would speak to the master through the agent. This is a workable sort of migration. There's nothing wrong with doing it this way, but there are benefits to be gained from doing a more proper lift and shift. The problem that we have here is in scaling. We come into a lot of the same problems that we have when we're working on premises. If we want to create another copy of the Puppet node, which serves the application, we have to set it up ourselves. We have to go in and configure it, SSH into the instance, do some configuration work on the master to get them talking to each other. There's almost as much work involved as there is in an on-premises application. Wouldn't it be nice if we could just click a couple of buttons and get an exact copy of the application defined by that Puppet manifest? We can do a more fluent migration while still allowing you to use the Puppet manifests and the Puppet knowledge that you and your team have built over the years by using these modules which Google has released to allow you to control your cloud infrastructure using Puppet in much the same way that you control your application using Puppet. This manifest is one that I've prepared as an example to assist with simple cloud migrations. Using a couple of clever tricks, which you can explore in the associated GitHub repository, it applies this shell script to install Puppet and the Puppet agent and apply the manifest from earlier to the GCE instance which is created. We'll apply this manifest to our local machine just like we would any other. We'll set a couple of variables for factor. First, the path to the credentials for GCP, and second, the name of the project that we're going to be creating these resources in. Then we apply it just like we would any other Puppet manifest. And you can see here that the instance is being created. We'll let that sit for a moment to give Puppet time to install the manifest. After a couple of seconds, we can check to see whether the manifest has been correctly applied, and we can see that it has. Here we have hello from create image from instance, which is the host name of the machine. Now that we know that the manifest has been applied, we can create an image from that instance. For that, we have another Puppet manifest, which we're calling GCP image from instance. It destroys the instance while leaving the disk and creates an image from that disk, which can be cloned as many times as we like. You can see that the instance here is being destroyed. while the manifest continues to apply. Aha, it seems that the image has been successfully created. And there it is. From this, we can create as many instances as we like. And once the instance finishes starting up, we'll be able to see that the same application is running there. And there we are. Hello from new instance. And this is a really great place for us to be because now we have the flexibility that Puppet allows us in configuring our application. Because, of course, our application is still defined by this Puppet manifest. If we wanted to, say, change the format of the date that gets displayed on that page, we just have to modify this Puppet manifest and then run through those steps again, and we'll produce a new, perfectly useful image that we can deploy to GCE instances in the future. I'll speed this up a little bit so that we don't have to watch the whole thing happen again. And there we are. Look at that. We get the new time format right there. And of course, we can do the same thing again to produce an image from that instance, which we already have. We've seen this before as well. And this is also a really fantastic place to be because the power of these modules that Google has produced, the Puppet modules for controlling your infrastructure, is much greater than just being able to start up a single instance. You can define your entire infrastructure in a single file like this, where you can see that we have our credentials defining an instance template, a health check, a target pool, an instance group manager, and a forwarding rule. In effect, we're starting up a cluster of machines from this single Puppet image, all behind a load balancer. This is the first thing that most large organizations are going to need to do with a very simple app. And similar to those other Puppet manifests, we can just run this Puppet apply command and create the entire GCP infrastructure, the complicated infrastructure, as defined in that file. So we'll watch as the infrastructure is created. We can go to the GCP console and look around and see the things that have been created, see the instance groups, for instance. But I think the most interesting thing for us to look at is going to be the load balancer that we created. So you can see here that we've created a target pool, which contains this instance group. And you'll see that GCP is automatically scaling this instance group, this managed instance group, up to our specified number of instances to 10. So we'll watch and wait as GCP spins up a much larger version of this project. And we can see here that some of these instances are coming online. And that means that we'll be able to access those instances through this load balancer. And there you see, we've got response from GCP infra load balanced instance GW42. There it is right there. And that concludes the demonstration of how easy it can be to do a lift and shift migration from an on-premises Puppet Master agent setup to a GCP instance group setup. And this is a great demonstration of the power of Puppet. What we have here is Puppet controlling the entire infrastructure of your application, in addition to being the source of the images which your application is deployed from. Thank you so much for watching. If you're new to GCP, you can get started easily at cloud.google.com/free. And make sure to use the short link on your screen to redeem an extra $200 in credits. We hope you'll find the scripts and the video helpful, and make sure to check out the rest of our work on the Puppet Forge. If you have any questions about what you've seen today, you can take a look at the README in the GitHub repo that should be on your screen now, or you can send me an email at nmckinley, that's NMCKINLEY, @google.com. Thank you.